service?
So I'm going to do a quick refresher for everyone, just to kind of give everybody context in terms of quote unquote context, if you will, of what microsegmentation is and the reasons why we've decided to move, or reason why we're moving now to this contextual based type of firewall, and why these attributes are necessary, or that we're seeing that they're things that our customers are asking for within the data center, right? So we're definitely going to take an application look at Application Rule Manager. For those that have not or have no idea what that product is, technically the Application Rule Manager was a feature that was released in NSX 6.3. It was a product that functionally what it did is you were able to actually collect the flow information that were coming from the VNICs of the virtual machines that would comprise an application. It would actually list all this information into a flow table, and from that flow table you could actually create your distributed firewall rules from that information. So it was more like if folks have kind of started this process, they're taking a look at like Log Insight, and you can get information from the distributed firewall for like Log Insight. And then as you started to move up and started to take a look at more applications or larger applications, something like Application Rule Manager would be where that would fall. And the last thing we're going to take a look at is our improvements with remote RDSH session hosts, and kind of where our identity-based firewall has gone, because we're now being able to help solve that use case, which is still definitely a use case for our customers. I want to make sure that folks understand that when I say RDSH, I don't necessarily just mean Horizon, but I also mean Citrix XenApp as well. So just a quick overview as we kind of get in here, right? So microsegmentation principles, right? It's all about our ability to provide isolation. So we can actually, within NSX, we can spin up logical networking. We can make faithful recreations of networking and actually have the same IP addressing, and we can provide complete isolation for those systems, right? So we can say that production systems cannot talk to the development environment, even though they could possibly reside on the same IP addressing. So we would have logical networks that don't even have access basically to the production network. So you can create faithful recreations for those. The next principle is around segmentation. So our ability to actually take the tiers of an application, so web app and DB for typical 3-tier application. For some applications like in the healthcare space, the N-tier application that could be multiple different items, even things like SAP that have multiple different products within them. But basically, the ability to segment out the different tiers, so presentation, application tiers, or business logic tiers, and then the database tier, and provide stateful firewall services to only allow the ports and protocols and communications that are necessary for that application to function. So if we only want to allow HTTPS 443 in the current implementation, or in our past implementation, if you will, of distributed firewall, we could write a rule that said we will allow inbound traffic to the web service or to the web tier, but we will only allow that security, we will only allow that communication to occur over HTTPS 443. Which means if you think about that from an attack surface perspective, right? You have this gigantic attack surface if you allow all ports and protocols. But now that I'm bringing it down to, say, one port and protocol, I've significantly reduced my attack surface by a factor of 9, right? And then the last thing is around this service insertion. So we know that in the current implementation, obviously, of a distributed firewall, that we were only going to layer 2 through layer 4, right? So we had this notion that we have partner relationships, and we still have these partner relationships, and they're still great, right? So we have relationships with our next generation firewall vendors, and they have the ability to plug into the NSX platform, and we can redirect traffic for depacket inspection, those kinds of services that would be required if necessary for that environment. Now again, we are kind of doing some things in the layer 7 space with around 50 applications, but we know that next generation firewalls offer threat prevention, IDS, IPS. They offer a ton more feature functionality that doesn't exist in the NSX platform. We know that, we acknowledge that, right? So our partner services through NetX APIs or EPSEC API, depending upon which kind of product it is, agentless antivirus, agentless malware, can connect in to the NSX manager and actually be deployed through NSX manager. And those services can either be brought off of the guest, so no more guest agents for like agentless antivirus and so forth, and be brought in, so like Trend Micro Deep Security, we can actually bring that product to the hypervisor and deploy it out for all the systems that ride on it. So all those platforms can plug in through the NetX APIs and the EPSEC APIs. Really what we're trying to do here is, and when I have this conversation with customers, the first thing they say is, you know, if you take kind of this model of how we do things from a security perspective, and then you have this perimeter firewall, if you decide like you want to bring in, you know, physical firewalls to manage your application traffic between different systems, it ends up becoming brittle, right? Because I don't know, I got to figure out which firewall rules I got to change for which application. Oh, I brought in a new firewall, I got a new app, now I have to make some, you know, modifications. And the firewall vendors have done a great job of, you know, using things like Panorama or Provider One or something along those lines to help with those, to help kind of get that holistic view of all the different firewalls. But it does become operationally very difficult to actually pull off. So if you think about kind of the traffic scenarios that we've seen, the whole 80-20 rule, right, of 80% of the traffic coming north-south or 20% coming east-west, it's kind of flip-flopped around, right? And, you know, I always say, don't believe me. We posted up there saying, you know, as a customer, you don't have to have NSX. You can run something like VRNI. Run it. It will actually tell you how much east-west traffic you actually have within your data center. And that if you go back, the app to database traffic and web to app, I mean, if you technically think about it, that's 60%, 66% of your traffic is technically going east to west within your data center. So how do I secure that traffic, right? So what we're doing with NSX is we're putting the distributed firewall, we're putting the firewall module into the kernel and into every hypervisor that exists within the data center. This creates a horizontal, basically a horizontal firewall that scales out and scales laterally as the workloads within your data center scale. Every virtual machine gets a stateful layer 2 to layer 4 firewall, now with 6.4, now having some layer 7 services, at the virtual NIC of every one of the virtual machines. So usually the response I get from customers is, hey, thanks, you just gave me 1,000 firewalls to manage. We can manage all of those firewall interfaces from the NSX Manager interface. And I'll show you when we get to the demo where we get to, you know, where we do that from. But when we do this by putting that, if you think about it from a physical perspective, switch with a server, you put a patch cable in, we're just putting a firewall in the middle of that patch cable. So now we can control the traffic not only, and I say layer 2 through 4, right? Which means you'd mentioned that there, you know, you have a /16, right, with hundreds of VMs or thousands of virtual machines running on that network. So you have a flat layer 2, right? For you to be able to do firewalling services on a flat layer 2 with physical devices, you'll need to know some MAC addresses, right? You're going to need to know a lot of that information. With NSX, it plugs into vCenter, and I no longer need to know that information because I'm already getting all of that context, all that inventory information from vCenter. So I don't need to know the MAC addresses. All I have to do is say, web to web, I'm blocking all traffic. As soon as I drop a machine into that group, I can basically block all traffic from that perspective.
And it's important, I think, where you're going as well, is even if it's on the same subnet.
Even if it's on the same subnet. So irrespective of the underlying networking, we're able to do this. Now, there's another distinction we should make here. You do not need overlay networking to perform micro-segmentation. For folks that don't understand that about NSX. NSX does have overlay capabilities, obviously, but you can run micro-segmentation on VLAN-backed networking. So there's no real reason for a customer to have to deploy overlay networks if they're not ready for that to get this security benefit.
Another isolation tool, but you don't need it.
Right, absolutely.
I spin up a dev network and then a production network separately, or
absolutely
to the nth degree, or I can just do it with a distributed firewall.
Yeah. So what exactly?
Wait, sorry, just a
go ahead.
question. You mentioned, so now instead of having, you know, X number of firewalls with where I put all my rules, you're distributing the rules out across a bunch of firewalls. So what's the argument there around complexity? Are we simplifying complexity, spreading it out? What happens with all the rule sets that have to be managed and maintained? And
Sure. So I would say that we're obviously simplifying complexity to some extent, to that extent, right? So we can, when we write our rule sets, within a distributed firewall, we're saying that our web servers can't talk to our web servers. So every web server that we actually place in there, that rule gets pushed down to the host that those systems reside on. This does not require any intervention from anyone in this room to actually make that happen, other than to write the rule.
It's one firewall.
It's one firewall.
It's one rule.
It's one firewall. So technically, if you think about it in terms of how we do routing, right, it looks like one router across all your hosts. It looks like one firewall. So you just manage it in that aspect. So from a complexity perspective, I don't have to go to firewall 32 to make my rule and then go over to firewall 25 where the two connect and make those changes. I make it in one place, and the firewall rules are distributed out to the host that those reside on. Now, the other thing that we should make note of too is that this is residing in the host, right? So that means that our virtual workloads can move vMotion-wise on any host, and the rules will follow it.
Policy's there already.
And
The security policy will follow it.
And the beauty of it is kind of, you don't care how many virtual firewalls are spawned up. For you, is it like one managed instance that you have to handle?
Yeah, so what I care about is my application and the rules that are necessary to run that application. That's what I care about as a security expert, right?
And then every time you add a server, you add more compute power to your firewalls.
Absolutely.
That's
As your workloads grow within for a company, right? I have 1,000 VMs today. I scale to 1,500, over the next year. I'm going to need more hosts. As I add more hosts, I add more firewalling capability. I don't have the slide up here, but technically, we get near line rate throughput because we're running in kernel for our firewalling services. So if you take a physical firewall that has multiple 10 gig interfaces, it's a very, very expensive firewall, right? You put multiple 10 gig interfaces into a x86 host, 10 gig interfaces are relatively cheap, but I'm getting firewall capability out of each one of those hosts. And think about it like this. If I have consolidation ratios, if I am running 20 virtual machines on one host, I only have to provide firewalling services for those 20 virtual machines on that host. I don't have one physical firewall that has to manage all the firewall capability and throughput for those 1,000 machines. I only have to manage it for the one host that those are residing on. So and if you have folks that are running, at scale for 10 gig throughput, most of our enterprise customers are not pushing anywhere close to that kind of throughput through those devices, right? So it becomes very, very robust in that regard.
just a quick insight. If you're running high loads, like you mentioned, the 10 gig, do you know what that means from a CPU consumption?
Sure, yeah. So I think the latest numbers in terms of running at scale are like between 3 and 5%. I mean, it's very, very low in terms of what we need to run at scale. And not only that, but most we've seen with vSphere hosts are typically CPU rich and memory kind of, memory's the more of the hard part to, the things you need to take into consideration, right?
But your goal is to just get security, context aware, right? So going beyond layer 4, but getting security as close to the application, in this case, and close to the VM running the application as possible. I mean, we've been talking about security and getting it built into the application. So that argument aside, getting it as close to the endpoint as you can. And that sounds like it's the goal in the longer term.
Yeah, absolutely. So with the first iteration, obviously, of the distributed firewall, we got as close as we could, right? Layer 2 through layer 4 firewall. To be fair, I hadn't had a lot of customers that needed to have east-west firewalling that really necessarily required layer 7 capabilities, right? Because technically, you more cared about deep packet inspection on the inbound on the north-south inbound to the actual application, right? I wanted to make sure that HTTPS was actually HTTPS just getting to my application.
Mm-hmm. Right.
But I did have customers, that wanted to secure a specialized application in terms of where we kind of first started this. I started to see customers start adopting more layer 7 capabilities with the product and more context where they needed this from an east-west perspective. We're in the healthcare industry. I came from the healthcare industry, and one of the applications that that my customer wanted to secure was a Schedule 1 drug application, right? That actually allowed clinicians to gain access or prescribe Schedule 1 drugs. So they wanted to inspect everything. but they didn't necessarily want to punt it to a physical device to actually make that occur, right? So we're bringing that closer to the application, and we're not having to traverse all those extra hops out to, say, a physical device to make that happen. So the natural kind of progression of this distributed firewall, right, is after the layer 2 through layer 4 is to, what other kind of context can we actually add to this system to make it past the 5-tuple type of perspective, right? So what do we mean by context awareness? And we started with east-west security. We added in some identity-based security, and we're going to talk a little bit more about how that works. But then this context-aware security, and what we really mean by this is, our ability to, do filtering and actually creating firewall policies based on user ID, VM, or user session, guest OS context, and then our ability to move from 5-tuple to, say, n-tuple, right? And when I say n-tuple, I mean adding even more context by saying, I want to create a firewall rule that has maybe HTTPS on this specific version of TLS, and then also maybe I want to add some more capabilities even further. As it sits right now, from an app identity and enforcement perspective, we do have support for a handful of ALGs. We're not feature-rich in terms of ALGs. I think we support total, maybe 10 or so, 8 to 10 or so ALGs at this point. Yes, before, some folks asked before in terms of where are we at in terms of layer 7 firewall, this context-aware firewall, and we're at about 50 or so services, right? So we had a slide that kind of listed them all out, but it's basically kind of an eye chart. So we'll point you folks to, to that offline so you can kind of get an idea of what we're talking about. And the last thing is around this protocol versions. So we first started with TLS and SSL because those kind of seem to be the more prevalent metadata information that we really kind of need to get out of some of these protocols, right? So we're starting with these and we're continuing to expand out and so forth.
Just a quick question. With a guest context, yeah?
Yeah.
I'm aware how you did it on the first version. A VM runs on the hypervisor, so you know already it's a Windows machine, a Linux machine. Mm-hmm. Okay, how do you do it with a user ID? How do you get this context?
I'm going to show you. Okay. I'm going to show you. There's, I've always been told from a demo perspective that the best answer is I got a slide for that. But actually the best answer for that is I got a demo for it.
Great.
So we're going to dig into Application Rule Manager. We call it ARM. I know some folks internally would probably be like, not another acronym. But, we call it functionally ARM. This is what we talked about before, this 80-20 rule, right? And I'm going to kind of speed up a little bit quicker than this. I'm going to kind of get to the meat and potatoes. But, this is down to these intra-application or these inter-application rules are the ones that are the more difficult ones to figure out. But they seem to be the ones that actually account for the most traffic within our data center. So, as we did things before in previous, this was kind of a single firewall table, and I got to go, I have one major, maybe perimeter firewall, one physical firewall that actually, all my applications run through, and it becomes a little bit more difficult to manage these things. So now, being able to do an application or a firewall per application means more granularity and us being able to actually account for some of these things. So what problem are we actually trying to solve here, right? So the problem that we're trying to solve here is we're actually trying to solve the problem of the complexity of actually doing all this. And when I say it's too complex, right? It's too complex. It takes a long time. And not only that, but it's still too manual, right? The process of actually doing all this is actually still really, really manual. When I say that, we have to set up our profiling. We have to figure out what our application is. We have to identify our rules. Then we have to go and have a conversation with our application folks to make sure that the rule sets that we're going to put in place are actually the ones that should be there. And then we have to test deploy, and then we got to do it all over again, right? And we do this for one application, and then I got to turn around and do it for the rest of them. That's not to say that micro-segmentation is easy. It's absolutely not. It's a process. But how do we make it? How can we make this easier for our customers? And the way that we're doing this is we're introducing what's called like smart planning, and the ability for the application rule manager to provide automatic recommendations based on the flows that it finds, and give you output and give you rules that you can publish to the distributed firewall. And not only that, do it very, very quickly. We're going to load the application. We're going to profile the app. We're going to analyze it. And then we're going to publish it out.
Now, I know you're going to show in the demo,
sure.
But will it also capture the process so I know that process is actually what port is matched to the process?
Sure.
Okay.
So that's something that we introduced in 6.3 with what's called endpoint monitoring.
Okay.
We're getting a little bit more into endpoint monitoring. Right now, it only supports the Windows-based systems right now for process. And then, so where that ends up coming in terms of NSXV, I don't have the time frames as far as where that's going, but the ability, you can with endpoint monitoring actually see the processes. When you run it against an application, you can actually see which processes are running, and you actually see the ports and protocols.
Okay.
But that information, translating that into ARM is not there yet.
Okay.
Is there a specific app that you had in mind where, okay, I know it's coming from this VM, but that's not enough information.
I just know how
I want to know
other
which
ones work.
thread within the VM.
To get accurate mapping, like in user, be able to say this user, so for a web server or something.
Right.
Maybe the Apache or HTTPD or whatever.
Number of stuff going on there.
The PID number, the process ID, not the process ID, but the process that was launched, the MD5 hash,
Sure.
all those other things that I can capture, but also be able to take that to map to the flow.
Right.
Be able to get a very, very accurate, because I might run, say, my web server off of a different port, right?
Right, and we can find out that you're running your web server off a different port because I can see that HTTPS traffic coming off of that different port, and I can show you, we can see which port it's coming from. So with layer 7 context, right, I can basically just say I don't care which port it comes from, but I do care that it's running TLS version 1.2. So I would write a rule that had a layer 7 app ID that had no port and protocol because I don't really care which port and protocol it is. I want the application.
With the application rule manager tab.
With application
then
rule
if
manager
you want
tab.
it, you could hop over to the endpoint monitoring tab and then look at the thread level.
Yeah, and then if you're familiar with the App Defense tool, that gives you MD5 hashing. There's a lot of other things that App Defense gives you. And the culmination of where those products are coming is still up in the air, but yeah.
Cool.
So how are we doing this, right? So the overview, it's around automatic recommendations, based on the flow data. We're going to allow a customer to manually intervene as they see fit, right? Because automation is cool until you have to make a change, and you can't make a change, right? So when you see some of these rule sets, you'll see them, and I know that every time I go to the distributed firewall and I see ARM recommendation 8425 UUID, that I remember exactly which rule that I'm looking at. So, I may want to actually make some slight modifications, and we're going to allow that ability for you to make the modifications to the security groups, to the actual rule names, et cetera, so that it makes a little more sense for customers. But in terms of the ability to actually do this, you don't have to make those modifications if you don't want to. And basically, again, this is around the stuff we've been talking about before. Faster time to value, faster time to day 2 operations as quickly as possible.